So hello everyone, welcome back to LeetCode Daily. In this particular video, we are discussing LeetCode daily problem of the day. The problem is minimum operations to exceed threshold value 2, and in this problem we have to given a zero index integer array nums and given an integer k, and in one operation you will perform these three conditions, and you can say these three statements. And also we have to given a note that you can only apply the described operation of if nums contain at least two elements, and then we have to return the minimum number of operations needed so that all elements of the array are greater than or equal to k. And now let's discuss this problem. And the first is we have to given a nums array and integer k, this nums and integer k, and our goal is to perform the certain operation until all elements in nums are greater than equal to k. And if it is possible, then we have to return their number of operations, like minimum number of operations which we have to perform here. And now like we have to given three conditions, and the first condition, take the two smallest integer x and y in our nums. And first we have to take these two values like x and y in our nums array, and also we have to remove both x and y from nums, and then we have to perform this operation like minimum of x comma y into 2 plus max of x comma y. And like this one is we have to get our new value. This is our new value, and after getting new value we have to insert it our new value back into our nums. And our task is to determine the number of operations needed to make all elements in nums at least k. Okay. And now so basically that zero index means the zero index integer array means arrays index starting from 0, so that the first element at index is 0, and then the second element is 1, and then so on. And then second is like in one operations, we have already discussed here, like in one operation means an operation refers to a single step where we can pick two smallest element, and then we have to remove it and then compute a new number and insert it our nums array after performing all these operations. And we have to remove it by using x and y, and x and y means physically delete the x and y both values from our nums array. And after we have to calculate a new number by using this operation, and then we have to insert it our nums. Okay. And now our goal is to minimize the number of operations required to ensure that every element in the array at least k, and we have to achieve by merging the two smallest number by iteratively by using until the condition is met, then we have to return it here. And now let's look at their example first so that you can understand. And in this example we have to given 2, 11, 10, 1 and 3, and k is given 10. And now initially this is our array, and let's suppose we have to sort it. Okay, sorted array, and this sorted is like 1, 2, 3, 10 and 11. And here we have to perform the operation like the operation 1, this operation 1 we have to pick smallest numbers like two numbers x comma y. The smallest is 1 comma 2. Okay, this is x and this is y. And after this we have to perform this operation of minimum of x comma y into 2. So basically we have to get the minimum element here, and also we have to find their maximum element also be here. Okay. And so first we have to discard x and y. So after discarding x and y we have to perform minimum of x comma y into 2, and then we have plus max of x comma y. Okay, and now after this what we have to get, we have to get the minimum of 1 into 2 plus maximum of both the values are 2, and here what we have to get, 2 plus 2 is equal to 4. So we have to get our new value is our 4, and our nums array is what is our nums array? Nums array is these two values become 4, and new array is 4, 3, 10 and 11. Okay, and now the next operation we have to take these two values, like we have to sort it. First we have to sort, and then we have to get 3, 4, 10 and 11, and this is our x, this is our y, and the x is equal to 3 and y is equal to 4. And now we have to get minimum of x comma y and into 2 plus max of x comma y, and we have to get x comma y of minimum is 3 into 2 plus, and this is our 4, max 4, and this is become 10. Now this becomes 10, and now this 4 and 3 value is 10, 10, 11, and now we have to get this is now our this is our operation 1, and this is our operation 2. Okay, and now our array is 10, 10, 11, and now all numbers are at least greater than is equal to k, because we have to given k value is equal to 10, and already we have to given in problem statement like minimum number of operation needed so that all elements of the array are greater than or equal to, greater than equal to means greater than or equal to k. Okay, and now here we have to get 10, 10, 11, and now how many operations we have to follow here, and we have to following two operation 1 and operation 2, so answer is our 2, so answer is 2. And now I hope you understand the example 1, and this is the simple one. And the second one example, we have to given a nums array of 1, 1, 2, 4 and 9, and we have to given k is equal to 20, and here initially we have there 1, 1, 2, 4 and 9, and the operation 1 is we have to pick 1 comma 1, 1 comma 1, and after compute this one, 1 into 2 plus 1 is equal to 3, and the array this will become uh, 3, 2, 4 and 9, and after sorted here 2, 3 and 4 and 9, and this is our new array, and after new array we have to perform another operation 2, and this operation we have to calculate this minimum, and minimum of 2 comma 3 plus sorry into 2 plus max of 2 comma 3, and why we have to we have to perform here operation like we have to already given here, and now this 2 comma 3 minimum is 2 into 2 plus 3 is equal to 7. Okay, and now new array is 7, 4, 9, and after sorted 4, 7 and 9, and how many operations we have to perform till time, we have to performing two operation at that moment. Now the operation 3 is we have to take these two values, these two values is 4 and 7, and minimum of this one is 4 into and 4 into 2 plus 7, this will become 15, and now these two values are become 15, 15 and 9, and this is our operation 3, and after sorted this will become 9 and 15, and after this we have to get minimum and maximum here, and the minimum is 9 into 2 plus 15 is equal to 33, and the array is become 33, and so now this will already greater than is equal to k. So how many operations we have to perform here, 1, 2, 3 and 4, and so answer is 4. Okay, so I hope you understand the example test cases, and now let's look at their constraint. So constraint we have to given 2 less than is equal to nums dot length and less than is equal to 2 into 10 to the power 5. And here the array can be large, so brute force solution can be O of n square. This is O of n square is slow, like this gives me a TLE solution. And after TLE, this one is also be 1 less than is equal to nums of I less than is equal to 10 to the power 9, and the values in array can be large, and this large value is up to 10 to the power 9. And similarly for here we have their threshold can be also be large, so 10 to the power 9 is also be here. And like O of n square solution is not work on this problem. And the like you can choose min heap and priority queue for the best choice, because of we have to extract the smallest element from all our nums array. So that extract minimum is you have to use optimally by using priority queue u of min heap, and so that we can use priority queue for performing operations. And the extracting from a heap is taking O of log n time, and this O of log n time making the overall complexity of this code is O of n log n time. So this is reduced by O of n square to O of n log n. So we have to perform this optimized solution of O of n log n. So let's look at their first. We have to look their brute force solution. So brute force solution is what we have to do. We have their nums array, and after nums array we have their answer for storing their count. Answer is equal to 0, and then we have to iterate by using a while loop, while 1. And this while loop we have to first sort it, and then we have to sort their nums, and after sort this taking O of n log n time. And after sorted we have their if nums of 0 greater than is equal to k, then we have to break the condition, because we have to get their condition is satisfied. And now we have their int x is equal to n0 and y is equal to n1, because we have to set the first and second index. Okay, 0 and 1 index, and then we have to erase it, like nums dot erase by using nums dot begin. Okay, and then same for here. And then we have their nums dot pushback. Nums dot pushback, we have to perform x into 2 and plus y, and this is our operation. And then we have to count plus plus answer plus plus, then we have to return answer. So this is the simple brute force solution for the code. Like we have to perform we have to store, like here we have to store the first and the second index, and then we have to erase it from their nums array 2 times, and then we have to push this x and y and perform the operation into our nums array. Okay, and now this is the complexity of O of n square. Okay, O of n square. And so now let's look at their optimized solution. This is our optimized solution. And so first we have to create a priority queue, and this priority queue we have their long int and vector of greater int of pq. And here we have to create a min heap of priority queue to store to always access the smallest element first, so that we have to use a priority queue here. And then we have to insert all element into our priority queue, and after inserting all the elements we have to count to keep the operations, like keep track the operation. We have their answer, and then here we have to perform the operations. Like in first operation we have their if priority queue is greater than is equal to 1, like process elements until all are greater than is equal to k. We have to perform this whole operations, and we have to check with all the possible values. Okay, and now here we have to get the smallest element here, and then we have to pop it, like we have to remove the smallest element from the heap. And then here we have their this tp greater than is equal to k means if the smallest element is already greater than is equal to k, then we have to return the operation and we have to return our answer. Okay, and then we have their pq dot size greater than is equal to 1 means if there is at least one more element in our heap, we have to perform the operation again. And then here we have there get the second smallest element. This second element means tp2 is we have to find their second smallest. Okay, and then we have to remove it from the second element from our heap, and then we have to perform this operation like t the first, like you can say this one is x, this one is y, and then we have to perform this x into 2 plus y. Okay, and the same thing we have to already perform here by using a vector. Okay, and here we have to use priority queue, and then we have to increment our operation answer plus plus. Then if there should never be reached because the constraint ensure a solution does not exist, like we have to return -1. Like if no operation is performed, then we have to return -1, you can say. And now why understanding like priority queue, how priority queue works on this problem. Basically a min heap is a binary heap where the smallest element is always at the top, and in each step we have there we have to extract two smallest number from our heap, and then after this we have their new value is equal to min of x comma y into 2 plus max of 2 comma y, and then we have to insert it our new value back into our heap, and then we have to repeat this process like greater than is equal to k time. And the priority queue operation is taking insertion operation is taking o of log n time, and the same for extract minimum of pq dot top and pq dot pop is taking o of again log n time. Okay, and this is the priority queue solution, and this is the simple priority queue solution, you can say. And the total time complexity of this code is we have there o of n log n solution for each operation. Like o of log n is we do most of operation is o of n time. Okay, o of n time, and then we have their priority queue like top, pop, and so on thing. Okay, and the space complexity of this code is we have o of n time because of we store all the element into our priority queue, so that it is o of n time. And now try run the first example. For that you can understand how priority queues work on this code. And here 2 11 10 1 3, and here 1 and 3, and the k value is 10. And here first we have their min heap basically what we have to get 1 2 3 10 and 11. And after this we have a first operation, we have to remove the smallest one, and this one is 1, and the second smallest is 2. And after removing this we have 1 into 2 plus 2 is equal to 4, and we have to insert it into our bag into our 4, and then heap is 3 4 10 and 11. Okay, and operation count is 1, and so on we have to perform all the operation. So I hope you understand the video and the logic between this minimum of x into y into 2 plus max of x comma x plus x comma y. And also we have to discuss their example test cases, and also we have their brute force solution and optimized solution of priority queue. So thank you everyone, thank you so much.